हेलो दोस्तों, आज हम डिस्कस करेंगे 20 मोर क्वेश्चन ऑफ सॉल्यूशन चैप्टर. लेट्स रीड द क्वेश्चन. Question number 1. The freezing point of equimolar aqueous solution will be highest for. First of all, let's consider how to approach this question. First, we need to understand the freezing point, that is depression formula is del Tf equal to IKFM. Then second step, we need to identify the constant. We know that the equimolar aqueous solution Kf, that is cryoscopic constant, and M, molality, is remain constant. Hence, depression in freezing point, that is del Tf, is directly proportional to the Van der factor. I indicates the greater freezing depression, means a lower freezing point. Let's analyze each compound. In option A, C6H5NH3Cl is present. When it dissociates, it will form C6H5NH3 plus and C minus. Hence, here I equal to 2. In option B, calcium nitrate is present. When it dissociates, it forms calcium 2 plus and 2NO3 minus. Hence, here I value is 3. In option C, LaNO3 thrice. When it dissociates, it forms La3 plus and 3NO3 minus. Hence, I value is 4. And in glucose, it does not dissociate. Has lowest Van der factor, that is I equal to 1. It will experience the smallest freezing point depression. The resulting highest freezing point is glucose. Here the Van der factor is less, that is 1. That's why here will be the highest freezing point. Let's move to another question. Here answer is option D, because I equal to 1. Whether lowest the Van der factor, highest will be the freezing point. Understand? Then move the next question, that is the molar elevation constant of water. Molar elevation constant of water is 0.51. Molar elevation constant of water means Kp is equal to 0.51. The boiling point of 0.1 molar aqueous NaCl solution is nearly. Here the molality is also given 0.1. Here we need to understand and put the formula of elevation of boiling point, that is del Tf, del Tp, elevation in boiling point, del Tp is equal to Kp into molality. Here Kp is given and I, Van der factor भी multiply होगा. Here I is equal to 2. Why 2? Because NaCl when dissociate it forms 2 ions, that is Na plus and Cl minus. That's why here I value is 2 and Kb value is 0.51 and molality value is given in question, that is 0.1. When we multiply this, we give that 0.10 degree Celsius. Here the boiling point of pure, we know the boiling point of pure water at 0 degree Celsius is 100 degree. The 100 degree Celsius, then the boiling point is boiling point क्या होगा? Boiling point equal to 100 plus 0.102. When we add this, we will have 100.1 degree Celsius. Hence the boiling point is 100.1 degree Celsius. Let's see the option. Here option B will be the correct answer. That is 100.1 degree Celsius. Next, Move to another question. In question number 3, a 5% solution of cane sugar, molar mass 342, is isotonic with 1% solution of substance X. The molecular mass of X is. Here we need to understand what is isotonic solution. Isotonic solution is same osmotic pressure. Here the osmotic pressure influenced by the molarity of solution, which can calculate using formula, that is molarity formula. Molarity formula is equal to weight of solute divided by molecular mass into 1000 divided by density of solution. First of all, we calculate the molarity of cane sugar solution. Here the weight of cane sugar is given. Weight of cane sugar is given. Weight of cane sugar is 5%. Molar mass of cane sugar. Molar mass of cane sugar is 342 gram per mole. Using formula, molarity of cane sugar is molarity of cane sugar is 5 divided by 342 into 1000 is equal to 14.62. Approx 14.62. Again, we need to calculate the molarity of substance, that is X. Molarity of substance X, weight percentage of the substance X is weight percentage of substance X is 1%. Using formula for molarity, and the molarity of substance X, molarity equal to 1 divided by molar mass of X into 1000. Next step, set up the molarities equal solution, that is isotonic. Here the isotonic solution is given, that's why the molarity of the cane sugar will be equal to the molarity of substance X. Molarity of cane sugar, we evaluate that 5000 divided by 342 is equal to molarity of substance X, that is 1000 divided by molecular mass of X. Here 30 cancel out. Mx, that is molecular mass of substance X, is equal to 342 divided by 5. When it cancel it, we get that 68.4 gram per mole. Let's check the option. Here option C is given, that is 68.4. This will be the correct answer. Next, move to another question. In question number 4, gives that the osmotic pressure of solution containing 4.0 gram of solute, the molar mass is 246 per liter at 27 degrees Celsius. Here we need to convert 27 degrees Celsius into Kelvin. 27 degrees Celsius equal to 27 plus 273.15. In first step, we need to convert the 27 degrees Celsius into Kelvin. 27 degrees Celsius equal to 27 plus 273.15 Kelvin. That is 300.15 Kelvin. In second step, we need to calculate the number of mole of solute. That is, number of moles of solute is weight of solute divided by molecular mass of solute. Weight of solute is 4 gram and molecular mass is 2246. When it cancel out, it gives 0.026. In third step, we assume the volume of solution. Here the volume of solution is not given. That we need to assume the volume of solution is is equal to 1 liter. Here the osmotic pressure formula, we understand that pi is equal to CRT. Here C is equal to concentration term and R is the universal gas constant and T will be the temperature. We can also write this, that is mole divided by molecular mass, RT. In simplify, we can also write moles, that is mass of solute divided by in concentration term, that is moles of solute present in 1 liter volume of solution, and RT is given. Mole, we can write that weight of solute present in molecular weight of solute into volume to RT. Let's put the given values in this formula, then we get the answer. Here we put these values, then multiply above numerator all numerator value, we get 98.52 divided by 246. When it cancel out, it will be 0.4. Answer is taken. Let's see the option. Here option C, that is 0.4 atm is the correct answer. Next, move the another question, that is, let's read the question. The phenomenon by which the plant derive water from their roots against the law of gravitation is called. The phenomenon that by which the plant derive water from their root against the law of gravitation is called osmosis. Okay. Then move another question. In question number 6, let's read the question. The molar boiling point of constant of water is 0.513 degrees Celsius kg mole inverse. When 0.1 mole of sugar is dissolved in 200 gram of water, the solution boils under pressure of 1 atm, that is atmospheric pressure. Here we need to understand what is given to us. Here given that Kb is 0.513 degrees Celsius, mole equal to 0.1, solvent is 200 gram, Here we know the formula, that is del TB is equal to Kp into molality. Let's put this del Tp is equal to Kp is given, that is 0.513 into molality. Molality is number of moles of solute present in solvent in kg, that is 0.1 moles of solute present in kg. ये ग्राम में है तो हमको 1000 से मल्टीप्लाई करना पड़ेगा. 0.513 into 0.1 divided by 200 into 1000. When we cancel out this 5 and multiply this, we find that here on 0.2565 is the answer. In question, it asks the solution boil under the pressure. What is its boiling point? Here the boiling point is asked. Then boiling point equal to boiling point at 0 degree Celsius and molar elevation in boiling point. We found that 0.2565. Let's add this. Boiling point is equal to 100 degrees Celsius plus 0.2565 is equal to 100.256 will be the answer. Let's look at the option. Here option C will be the correct answer. Let's look the recent entrance MCQs. This question asked in CPSE 2000. Let's read the question. Which of the following colligative property can provide the molar mass of the protein with great precision? Colligative property that can provide the molar mass of the proteins, polymers or colloids with great precision of osmotic pressure. Here the great precision, that is osmotic pressure. Here the option B single is present, that is osmotic pressure. Osmotic pressure will be the correct answer. In question number 8, an aqueous solution freezes at -0.186 degrees Celsius. Cryoscopic constant is 1.86 and elevation constant is 0.512. What is the elevation of boiling point? It is the most important PYQ asked in OJEE and AIIIE. Let's calculate. Here given, that is the del TF is 0. Del TF means depression in freezing point is 0.186. Depression in freezing point is 0.186 and cryoscopic constant is 1.86. Elevation constant is 0.512. Here ask that elevation in boiling point. What is the elevation in boiling point? Let's calculate this. We should be remember the formula, that is del TF divided by del TB is equal to KF divided by KB. Let's put the value, that is del TF is 0.186 divided by del TB is equal to the 1.86 and Kb value is 0.512. Let's cancel this. Here 0.1 is present. Del Tb is equal to 0.1 into 0.512. Then when it multiply 0.0512 is given. That let's check the option, that is option B, 0.512 is the correct answer. Let's move to another question. Question number 9 says, let's read the question. The relation between the coefficient of viscosity of a liquid and temperature of liquid and temperature can be expressed as. Here we know the relation, that is coefficient of viscosity is related to absolute temperature T by Arrhenius equation. Here the option D is the correct answer. It is the correct relation between the coefficient of viscosity of any solid liquid and temperature can be expressed in this equation. Let's move to another question, that is question number 10. In a 0.2 molar aqueous solution of a weak acid HX, the degree of dissociation is 0.3, taking kf of water as 1.85. The freezing point of solution will be nearest to. The weak acid is dissociated partially. The weak acid here is, that is HX, which dissociates partially. Degree of dissociation given is 0.3. Let's calculate. Here when HX dissociates, H plus and X minus is present. Here 1 minus alpha is equal to alpha and alpha. Here the degree of alpha is the degree of dissociation. 1 minus degree of dissociation, that is 1 minus 0.3 is equal to 0.7. The moles of HX is 0.7. The moles of H plus is alpha, that is 0.3, and moles of X minus is alpha, that is 0.3. That is given in question. Total particle present is total particle present is equal to 1.3 plus 0.3 plus 0.3. Sorry. Total particle number of moles of HX is 0.7 plus number of moles of H plus is 0.3 plus number of moles of X minus is 0.3. When it adds this, we get 0.13. Sorry. When it add, we get 1.3. Here we apply formula, that is del TF is equal to IKF M I is equal to 1.3 into Kf is 1.85 into molality is 0.2 is equal to 0.48 degrees Celsius. Here TF The freezing point is 0 degree Celsius. The freezing point, here we calculate, that is 0.48 equal to minus 0.48 is the correct answer. Let's see the option. Here option D will be the correct answer. Let's move another question. In question number 11, let's read. During depression of freezing point in a solution, following are in equilibrium. To solve this question, we need to understand equilibrium. Freezing point, the liquid solvent and solid solvent are in equilibrium. This means that the rate at which the liquid solvent freezes into solid is equal to the rate at which the solid solvent melts back into liquid solvent. That's why here the liquid solvent and solid solvent will be in equilibrium. Liquid solvent and solid solvent. Option liquid solvent and solid solvent. Here option A is the correct answer. Let's move to another question, that is question number 12. Let's read the question. After adding a solute, freezing point of aqueous solution decreases to minus 0.18 degrees Celsius. Calculate elevation in boiling point if freezing point constant, that is cryoscopic constant, is 1.86 and boiling point constant is 0.521. Let's calculate. Here the same formula we need to consider, that is del T. Here we need to find elevation in boiling point. The formula is elevation in boiling point, depression in freezing point equal to Kb divided by cryoscopic constant Kf. Put the value and get the answer. Del Tb is equal divided by depression in freezing point given 0.186 equal to Kb value is given in question, that is 0.521 divided by 1.86. Here when we cancel this, here 0.1 is present. Exactly same question repeat हुआ है. Del Tb is equal to 0.521 into 0.1 equal to 0.0521. Hence the correct answer is del Tb is equal to 0.0521. Yay. Okay, let's move the next question. Question number 13. Let's read the question. That is 0.02 into 10 to power 20 molecules of urea are present in 1000 ml of its solution. Concentration of urea solution is, its simple concentration means moles of solute present in 1 liter volume of solution. Simple. Here first we need to calculate number of mole. The number of mole is number of particle divided by Na. Number of particle is given 6.02 10 to power 20 divided by Na. Number of particle is 0.02 into 10 to power 20. Na value is 0.6 into 10 to power 23. When we cancel this, we have 10 to power minus 3 is the mole. Then the concentration is 10 to power minus 3 mole divided by 1000 ml. 1000 ml दी हुई है तो हमको 1000 से मल्टीप्लाई करना पड़ेगा लीटर करने के लिए. तो 1000 कट गया तो 10 to power minus 3 तो हम इसको लिख सकते हैं 0.001 m. Here the option C is the correct answer. Let's read the question. The camphor is often used in molecular mass determination because of it has a very high cryoscopic constant. Okay, let's move to another question, that is question number 15. A 0.004 m solution of Na2SO4 is isotonic with 0.010 m solution of glucose at the same temperature. The apparent percentage dissociation of Na2SO4 is when Na2SO4 is dissociated. When Na2SO4 is dissociated, it forms 2Na plus and plus SO4 2 minus. Let's solve this question. That is, when Na2SO4 dissociates, if the mole of Na2SO4 is given 0.004 minus x, here 2x and only x is present, total concentration is 0.004 minus x plus 2x plus x. Here x is cancelled. 0.004 plus 2x is equal to 0.01. Since the solution is isotonic, so 2x is equal to 0.01 minus 0.04 is equal to 0.006. X is equal to 3 into 10 to power minus 3. Percentage of dissociation is 3 into 10 to power 3 into 10 to power minus 3 divided by 0.04 into 100. here पॉइंट से 1 10 to power minus 3 कट जाएगा and 300 divided by 4 when it cancel it 75 आएगा 75%. Let's check the option. ये here हमारा ऑप्शन सी 75% इज द करेक्ट आंसर. IIT 2004 में पूछा गया था ये क्वेश्चन. In which of the following liquid pairs show positive deviation from Raoult's law? Here benzene methanol it show positive deviation from Raoult's law. That is where the benzene is the non-polar and methanol is polar. When it makes, the intermolecular interaction decreases, causing an increase in escaping tendency of both liquid. Thus, it forms the positive deviation from Raoult's law.